Hello my friends, and welcome back to KrossUSA channel. From the forests of America to cutting-edge mills across the globe, join us as we explore how master craftsmen and modern technology transform raw timber into precision lumber. These aren't your grandfather's sawmills. This is industrial woodworking at its absolute finest. You know, there's something deeply satisfying about watching raw timber transform into precision-crafted lumber, and nobody does it quite like Desch Holz. This German powerhouse has been perfecting the art of sawmilling for generations, and what we're seeing here is a masterclass in modern timber processing that would make the old-time sawyers shake their heads in wonder. Now, Desch Holz isn't just any sawmill. They're processing some of Europe's finest softwoods, primarily spruce and pine from sustainably managed forests. What makes their operation fascinating is how they've married traditional German engineering precision with cutting-edge automation. Back in the day, sorting logs was back-breaking work done by eye and intuition. Today, at Desch Holz, incoming logs roll through an automated sorting system that's nothing short of remarkable. NTHE Log Yard is where the magic begins. Each log gets scanned by optical sensors that measure diameter, length, and even detect internal defects using what's called computed tomography, essentially a CT scan for trees. This technology didn't exist until the late 1990s, and it revolutionized the industry by letting mills see inside the log before making that first crucial cut. The system assigns each log to specific production lines based on its quality grade, maximizing yield and minimizing waste. Watch how those heavy logs move through the debarking station. That rotating drum you're seeing, that's stripping away bark using high-pressure water jets and mechanical friction. The bark isn't wasted, mind you. It gets collected and used for biomass energy, heating the facility and nearby homes. That's the kind of circular economy thinking that old-timers would appreciate. Nothing goes to waste. Now we're approaching the heart of the operation, the primary breakdown saw. Desch Holz runs what's called a frame saw system, a design that traces its roots back to the medieval period, but has been refined into a high-precision machine. This isn't your grandfather's bandsaw mill. We're looking at a multi-blade gang saw that can process logs up to 60 centimeters in diameter, making multiple cuts simultaneously at speeds that would have been unimaginable 50 years ago. The saw is computer-controlled, adjusting blade positioning in real time based on that initial scan data, positioning each log to extract maximum value from every fiber. And here's something that really showcases German engineering: the optimization software. It's calculating hundreds of potential cutting patterns per second, deciding whether to produce construction lumber, furniture-grade boards, or specialty products. The system accounts for market demand, wood grain patterns, and even knot locations. In the 1950s, a skilled sawyer might process 20 logs per shift. Today's automated systems at Desch Holz handle that many logs in an hour, with less waste. And after the primary breakdown, the cants, those are the large, squared sections, move to the secondary processing line. This is where precision really matters. The Egger saws trim away irregular edges, creating boards with perfectly parallel sides. Then comes the trimmer, which cuts boards to exact lengths based on grade and customer specifications. Every cut is measured to the millimeter, something that's only been possible with laser-guided systems introduced in the 1980s. NTHE grading station is equally impressive. Automated scanners evaluate each board for knots, grain patterns, color consistency, and moisture content. Boards get sorted into grades ranging from clear premium lumber for fine woodworking down to utility grade for construction. This automated grading removes human inconsistency and operates at speeds of up to 200 boards per minute. What you're seeing now is the stacking and packaging area. Boards of similar dimensions and grades get bundled together with precision strapping machines. Notice how they're being stacked with spacer sticks. Those are called stickers in the trade, which allow air circulation for proper drying. Even though modern kilns do most of the drying work, proper stacking has been a sawmill fundamental for centuries. Desch Holz's finishing line includes planing mills that smooth rough-sawn surfaces to silky perfection, producing what's called dressed lumber. The planers can achieve tolerances of plus or minus 1/32 of an inch, precision that hand planing could never match. This is where raw timber becomes the beautiful uniform boards you'd find at a quality lumber yard. NTHE Whole operation runs with remarkable efficiency, processing thousands of cubic meters of timber weekly while maintaining strict quality standards. It's this combination of tradition and innovation that keeps European sawmills like Desch Holz competitive in the global marketplace, producing premium lumber that craftsmen and builders trust. Welcome to the heart of Switzerland's Entelbuch Biosphere Reserve, where the Schmid family has been turning mountain timber into quality lumber for generations. What makes this operation special isn't just the sawmill itself. It's the complete journey from forest to finished product, all happening within one of Europe's most pristine natural environments. Let's start where it all begins, deep in those alpine forests. The logging operation you're witnessing uses modern harvester machines, but there's still tremendous skill involved. These aren't the chainsaws and axes of yesteryear. Today's harvesters are sophisticated pieces of equipment that can fell, delimb, and buck a tree to length in under a minute. The operator sits in a climate-controlled cab, using joystick controls to manipulate a cutting head that grabs the tree, cuts it at the base, strips the branches, and sections it into logs, all in one smooth operation. This technology only became widespread in the 1990s, transforming logging from one of the world's most dangerous jobs into a much safer, more efficient profession. Watch how those logs get loaded onto the timber trucks. These specialized vehicles are built to handle the mountainous terrain around Entelbuch, with articulated frames and all-wheel drive. Each truck can carry anywhere from 15 to 20 tons of logs, and they're equipped with self-loading hydraulic cranes. Back when I was young, loading logs was done with chains, winches, and a whole lot of muscle. Today's systems can load a full truck in 15 minutes. Now we're arriving at the Schmid mill yard. The first thing you'll notice is how organized everything is. Logs are sorted by species, primarily spruce, pine, and fir from the local forests, and by size class. The Entelbuch region has been producing timber for centuries, and Swiss forestry practices are among the most sustainable in the world. Every tree harvested is part of a long-term management plan that ensures the forest remains healthy and productive for future generations. NTHE Schmid operation uses what's called a log deck system for feeding their primary saw. You can see how logs are positioned in the trough, then automatically advanced and rotated for optimal cutting. That initial positioning is crucial. It determines how much usable lumber you'll get from each log. Modern optical scanners help, but experienced sawyers still rely on intuition developed over decades of work. And their debarking system uses a ring debarker design, where the log rotates while cutting tools follow its contours, removing bark efficiently without wasting valuable wood. The Schmid family uses that waste bark in their own biomass heating system, a practice that's become standard in European sawmills. It's remarkable how the industry has evolved, from burning waste in open pits to using it as renewable energy. NTHE main saw line at Schmid is a horizontal bandsaw configuration, a design that's been popular in European mills since the 1970s. Unlike circular saws that remove more material with each cut, what we call kerf, bandsaws make thinner cuts, recovering more lumber from each log. The blade is a continuous loop of steel running over large wheels, and it's moving at speeds approaching 100 feet per second. The precision is extraordinary. We're talking about cutting tolerances measured in fractions of millimeters. And after the primary breakdown, boards move through an automated sorting system. Sensors measure thickness, width, and length, checking for defects like knots or splits. High-quality boards destined for furniture making get separated from construction-grade lumber. This automated sorting has only become economically viable for smaller mills like Schmid in the past 15 years, thanks to decreasing technology costs. NTHE edging and trimming stations are where boards get their final dimensions. Computer-controlled saws optimize each cut to maximize value while meeting customer specifications. In traditional mills, this was done manually by skilled operators who could read the wood and make split-second decisions. Today's systems make those same decisions thousands of times per hour, but the principle remains the same. Get the most value from every piece of wood. NTHE Schmid Sawmill represents a perfect balance between modern efficiency and traditional quality. They're producing lumber that meets exacting specifications, while maintaining the character and integrity that comes from working with locally sourced timber from sustainably managed forests. It's this connection between forest and finished product that makes operations like Schmid special in today's globalized lumber market. Now we're entering an entirely different world of wood processing, the fascinating realm of engineered wood products. K-Board's particle board manufacturing facility represents one of the most efficient uses of wood fiber ever developed, turning what was once considered waste into valuable building materials. NP particle board, also called chipboard, has an interesting history. It was actually developed in Germany during the 1940s when solid lumber was scarce. Engineers realized they could bind wood chips and sawdust together with adhesives to create sheet goods that were stable, uniform, and cost-effective. Today, it's an essential material in furniture making, cabinetry, and construction worldwide. NNTHE process starts at the wood yard, where raw material arrives in various forms. Logs too small or defective for sawmilling, slabs from sawmill operations, and clean recycled wood. All of this gets fed into massive chipping machines that reduce it to uniform pieces. These drum chippers, invented back in the 1920s and perfected over decades, can process several tons of wood per hour. The chips fly out at high speed, and the sound is like standing next to a continuous thunderstorm. NBUT. Here's where it gets technical. Not all chips are created equal. K-board uses screening systems to sort chips by size. Larger chips go into the core layer of the board, while finer particles are reserved for the surface layers. This creates a density gradient that gives the finished board smooth surfaces perfect for veneering or laminating, while keeping costs down with a less dense core. Watch those chips moving through the drying system. Moisture content is critical in particle board manufacturing. Too much moisture and the adhesive won't bond properly. Too little and the chips become brittle. The rotary dryers you're seeing heat the chips to precise moisture levels, typically around 2 to 4%. These dryers operate at temperatures exceeding 600 degrees Fahrenheit, and they're monitoring and adjusting constantly to maintain consistency. And now comes the blending stage, where adhesive resins are applied to the dried chips. K-board uses advanced resin systems, typically urea formaldehyde or melamine urea formaldehyde formulations for interior applications. The resin gets atomized into a fine mist and mixed with the chips in rotating drums, coating each particle evenly. Modern formulations use far less resin than earlier products, reducing emissions while maintaining strength. NTHE forming station is where the magic happens. Chips rain down onto a moving belt in controlled layers. Fine particles on bottom, coarse in the middle, fine on top. Precision weighing systems ensure consistent density across the entire mat. The mat is several inches thick at this point, but it's about to get compressed dramatically. Into the hot press it goes. This is the heart of the operation, a massive hydraulic press that can exert thousands of tons of pressure while heating the mat to around 400 degrees Fahrenheit. The combination of heat, pressure, and time causes the resin to cure, bonding the chips into a solid, dense panel. The press cycle takes just a few minutes, but everything has to be perfect. Temperature distribution, pressure profile, timing. Modern presses are computer-controlled marvels that can produce boards with remarkably consistent properties. What emerges is a continuous ribbon of particle board that gets cut to standard sheet sizes, typically 4 by 8 feet for the North American market. Edge trimming saws clean up the sides, and the boards move through cooling stations before final processing. NTHE finishing area is where boards get sanded to precise thickness tolerances, sometimes receiving surface treatments or veneers. Quality control systems check density, thickness, moisture content, and internal bond strength. Modern particle board is an engineered product with properties that can be more predictable than solid wood. NK Board's operation exemplifies how the wood industry has evolved from simply sawing logs into boards to utilizing every fiber efficiently, creating materials that serve specific purposes in modern construction and manufacturing. Green Tree Forest Products represents American sawmilling at its finest, a state-of-the-art operation equipped with some of the most impressive machinery you'll find in the timber industry. What we're looking at here is equipment from Mellet Manufacturing, a company that's been building sawmill systems since the early 1900s, and their latest generation of equipment is something to behold. Let's start with that Mellet Extra Heavy Duty LMR 48-inch debarker. Now, debarking might seem simple, but this machine is a sophisticated piece of engineering. The 48-inch refers to the maximum log diameter it can handle. That's a 4-foot wide log, folks. The debarker uses a combination of rotating toothed rings and hydraulic pressure to strip bark cleanly without gouging into the valuable wood underneath. What makes this system extra heavy duty is its ability to handle the hardest, most resinous species without slowing down. In the Pacific Northwest or the southern pine regions, that durability is essential. NT Ho's WH124 log decks feeding the debarker are engineering marvels in their own right. They're essentially massive chain conveyors that can hold dozens of logs in queue, automatically advancing them one at a time. The 124 designation refers to the width in inches over 10 feet wide. These decks can handle logs weighing several tons each, positioning them precisely for the debarker. Back in the day, this positioning was done with pike poles and brute strength. Today, it's all hydraulics and computerized controls. NTHEWDH 120 log trough is where logs sit after debarking, waiting to enter the main saw. This trough system uses what's called a sharp chain conveyor. Imagine a massive bicycle chain with pointed teeth that grip the log and move it forward. The 120 indicates it's a 10-foot wide trough, capable of handling even the largest logs. The precision of these systems is remarkable. They can stop, start, and position logs within fractions of an inch. Now let's talk about that bark removal system. The heavy-duty vibrating conveyor feeding the troughing idler belt conveyor. This might sound technical, but it's solving a real problem. Bark needs to be removed from the area quickly, or it piles up and creates hazards. The vibrating conveyor literally shakes the bark along, while the troughing belt, which forms a U-shape to contain the material, carries it away for processing into mulch or boiler fuel. Millet pioneered these integrated waste handling systems in the 1960s, recognizing that efficient waste removal was just as important as efficient sawing. NNTHAT extra heavy drop belt with pan type can't lift is handling the heavy timbers after the primary breakdown. Here's how it works. After the head rig makes its initial cuts, you've got these large squared sections called cants that need to move to secondary processing. The drop belt is a heavy conveyor that literally drops down to receive the cant, then lifts it using a pan mechanism and transfers it to the next station. This eliminates manual handling of pieces that might weigh hundreds of pounds. It's the kind of safety innovation that's made modern sawmilling far less dangerous than it was in previous generations. NTHE resaw runaround system is particularly impressive. This is where cants get broken down into dimensional lumber. The heavy 81XH timber deck moves the cants to the resaw, which makes multiple parallel cuts to create boards of specific dimensions. The sequencing stops are computer-controlled gates that organize the flow of material, while the 10-inch roll cases, those are powered rollers spaced 10 inches apart, transport the boards smoothly. The H78RT/81XH transfers are automated systems that move lumber between different processing lines. In a high-volume mill like Greentree, managing traffic flow is as complex as managing a busy intersection. NTHE Sawyer's cab with dual captain's chairs is where the head sawyer operates. In modern mills, the sawyer isn't manually moving levers and wheels. They're using joystick controls that interface with computerized optimization systems. The dual chairs allow for training and supervision, with both positions having full visibility of the operation. Those joystick controls can command dozens of functions, advancing logs, rotating them, adjusting saw positions, even controlling the speed of the entire line. It's like piloting a very expensive, very productive aircraft. And after sawing comes grading, and that transfer to unscrambler feeding the grading line is crucial. Boards coming off the resaw are jumbled and overlapping. The unscrambler uses a combination of chains and kickers to separate and align boards into a single file line, presenting each board to the grading station perfectly positioned. The grading line uses optical scanners and trained graders working together to evaluate and sort lumber by grade, select structural, number 1, number 2, utility, and so on. And finally, those waste removal systems are the unsung heroes of the operation. Every cut produces sawdust, every log produces chips and trim ends. Millet's waste removal systems use a network of conveyors, blowers, and collectors to keep the mill floor clean and safe while capturing valuable material. That sawdust gets sold for animal bedding or pressed into pellets. The chips go to paper mills or particle board plants. Even the trim ends get chipped and used. A modern sawmill like Greentree might generate revenue from waste streams that rivals their lumber sales from decades past. What makes Greentree's millet installation special is how all these systems work together as an integrated whole. Every piece of equipment communicates with every other piece, creating a synchronized production line that maximizes both efficiency and safety. It's American manufacturing excellence on display, processing the renewable resource that literally built this nation. here's something you don't see every day: a mill that's processing bamboo instead of traditional timber, and not just any bamboo, but guadua bamboo from South America. Ecotableros is pioneering sustainable panel production using one of nature's most remarkable plants, and the process is absolutely fascinating. Guadua bamboo deserves some explanation, because this isn't the decorative bamboo you might have in your garden. Guadua angustifolia is a giant tropical bamboo native to South America, particularly Colombia and Ecuador. It can grow over 100 feet tall and reach 8 inches in diameter. But here's what makes it revolutionary for manufacturing. It reaches full maturity in just 3 to 5 years, compared to 30 to 80 years for most timber trees. Imagine harvesting a crop every 3 years instead of every generation. That's the sustainability advantage of bamboo. NTHE raw guadua culms, that's what we call bamboo stems, arrive at the Ecotableros facility fresh from managed bamboo forests. Unlike trees, harvesting bamboo doesn't kill the plant. You cut mature culms, and the root system sends up new shoots that grow incredibly fast, sometimes several inches per day during peak growing season. And watch how they're processing these culms. First comes splitting. Each hollow bamboo stem gets split lengthwise into strips. Specialized splitters accomplish this rapidly, following the natural fiber direction. Then those strips get flattened, using pressure and heat. Bamboo's natural round form has to be pressed flat to create usable material, and this requires precision. Too much pressure, and you crush the fibers. Too little, and the material won't stay flat. NTHE next stage is removing the outer skin and inner membrane. Bamboo has a hard, silica-rich outer layer that's great for the living plant, but problematic for adhesive bonding. Planing machines remove this layer, exposing the fiber-rich core material. This is similar to peeling veneer in traditional plywood production, but the properties of bamboo require specialized cutting angles and speeds. Now comes carbonization for some products. You'll notice some strips are darker than others. This heat treatment not only creates that rich caramel color that's popular in flooring and furniture, but it also increases dimensional stability by reducing the material's tendency to absorb moisture. The carbonization process involves heating the bamboo strips in controlled ovens at temperatures around 280 degrees Fahrenheit. NTHE strips get coated with adhesive. Ecotableros uses environmentally friendly formaldehyde-free resins, continuing their sustainability commitment. The adhesive-coated strips are then laid up in layers, with grain directions alternating like traditional plywood construction, and into the hot press they go. The pressing parameters for bamboo are different from wood. The density is different, the fiber structure is different, and the optimal bonding conditions have been developed through research and experimentation. What makes this operation significant isn't just the use of bamboo, it's the demonstration that sustainable, rapidly renewable materials can meet industrial demands for quality and consistency.